You're listening to DTF HN for July 31st, 2026. I'm your recursively unshackled host, Jack Haxman. We are your daily tech feed for Hacker News, a website where mass quitting your job and refreshing the front page are somehow the same lifestyle. Today smells like open blueprints and well-aimed defiance. Strap in. Your entire conversation history, every correction, every preference, every piece of context you've painstakingly built up with an AI model belongs to someone else. Close your account and it vanishes. Switch providers and you start from zero. Every relationship you've built with these systems is a tenant relationship. You don't own the leap. Armin Ronacher and team at Arundel published a piece this week laying out the session portability problem in AI. And the precision of the argument is what makes it sting. When you work with an AI assistant over days or weeks, you're building something. A shared context, a set of preferences, a history of corrections that makes the model more useful to you specifically. That accumulated session state is genuinely valuable. And right now, it's trapped. Run this forward 5 years. AI assistants become deeply integrated into how people work. Coding, writing, research, decision-making. The session history becomes a record of how you think, what you've built, what you've learned. Now imagine you can't export it. Imagine switching from one AI provider to another means abandoning months of collaborative context. That's not a minor inconvenience. That's lock-in at the cognitive layer. The technical shape of a solution is straightforward. A user should be able to export their session data in a standard format, close an account, and hand that context to a different model. The new model might perform differently. It might disagree, to ask clarifying questions, lose some nuance. That's a fair contract. What's not fair is making the exit cost so high that switching becomes irrational even when a better tool exists. The community response is telling. Some people argue conversations are disposable. Just keep notes in your repo. Let the AI rederive context each time. And sure, that works for some workflows. But it's also a workaround for a problem that shouldn't exist. The fact that people are building their own inference tool chains and harnesses specifically to avoid provider coupling tells you everything about where the friction actually lives. This is an architecture problem, and the architecture reveals the incentive. Closed session data keeps users on your platform. Open session data lets users choose the best tool for the job. One of these serves the user. The other serves the quarterly earnings call. The tools to solve this exist. Standard formats for conversation export. Open protocols for session handoff. The question is whether the major providers will implement them voluntarily, or whether the open source ecosystem builds around them first. History suggests the answer. There's 380 words. Want me to adjust tone, length, or emphasis? Moving on. 13 years. That's how long a sandbox escape lived in Chrome's codebase. A bug that let a compromised renderer trick the browser into reading local files, sitting there patiently through thousands of code reviews, millions of fuzzing runs, and an entire generation of security researchers. Google's own blog post drops this number almost casually, like it's color commentary rather than the whole story. In June 2026, Google fixed more Chrome security bugs than they had in the previous 2 years combined. The mechanism was an AI agent harness built on Gemini that crawls Chrome source code looking for vulnerabilities. And the results are genuinely impressive. But here's where the comedy of unintended consequences kicks in. They got so good at finding bugs that their own vulnerability reward program broke. External researchers started submitting more reports in March than Google had received in all of 2025, partly because the same AI tools researchers use got better too. Google's response was to restructure the VRP to focus on submissions. additive to what we are finding internally. Translation. We automated ourselves into a position where we had to change the rules because everyone else automated too. This has a historical rhyme. In 1988, Robert Morris launched the first major internet worm, and the response was CERT, the first computer emergency response team. The pattern is always the same. Capability scales. Then the infrastructure for handling that capability has to scale. Then the governance around the infrastructure has to scale. Google just compressed that cycle from years into months. Now, the open-close question. Google built a knowledge base from Chrome's entire Git history and every previously identified CVE. They added support for model interoperability across open weights and proprietary models. They introduced security.nd files so models can understand trust boundaries. That architectural choice, making the security context machine readable and model agnostic, is genuinely good engineering. The irony is that this approach works precisely because Chrome itself is open source. Chromium's public codebase, public CVE history, and public Git log are what make the knowledge base possible. Google is reaping the returns of openness while the model's doing the reaping run on lockdown machines, with no internet access and strict allow lists. One commenter asked the right question. How many of those automated fixes were reverted? How many introduced new bugs? The blog post counts everything that went right and nothing that went wrong. That's marketing, not engineering. But the 13-year sandbox escape is real. The capability is real. And the fact that it works best on open code bases with public histories tells you something about which development model actually produces more secure software in the long run. The tools work. The question, as always, is whether the methodology stays open enough for everyone to use them. Completely different energy now. Story 3. Java just got one of its most requested language features, and it's a beaut. Let me make the case against this. Java is a 29-year-old language. Every new feature adds complexity. Every preview GEP is another thing developers have to learn. Another edge case in the spec. Another year before the ecosystem catches up. The JVM already has escape analysis. Hotspot already elides allocations in many cases. Do we really need to change the object model itself? The thing everything else is built on. For what amounts to a performance optimization, that's the strongest version of the argument, and it falls apart on first principles. Here's what a value object actually is. Strip away the JEP language. Strip away the Valhalla branding. At the hardware level, your CPU doesn't know what an object is. It knows memory addresses and cache lines. Every time Java wraps an integer in an integer, it creates a pointer to a heap allocation. That pointer has to be followed. That heap allocation has to be garbage collected. That indirection is not a feature. It's a tax. A tax on every generic collection, every optional, every domain type that should be 3 fields laid out flat in memory, but instead becomes 3 pointers chasing 3 allocations, scattered across the heap. Value objects remove the tax. A value class declares that its instances have no identity. 2 points with the same x and y are the same point, full stop. The JVM can now flatten them in line, pack them into arrays contiguously, skip the object header, skip the identity checks. This is not an optimization hint. This is a semantic contract that unlocks a fundamentally different memory layer. What makes this serious is the scope. Integer, long, double. The primitive wrappers themselves become value classes. Every autoboxed integer in every Java program on Earth gets faster. The backward compatibility work required to pull that off without breaking existing code is staggering, and the OpenJDK team has been methodical about it for years. One commenter pointed out, "This is only the first part of Valhalla. Specialized generics are still missing." That's true. You still can't write list of int without boxing, but the foundation has to come first. And this is the foundation. This matters because Java runs the world's back-end infrastructure. Not in a marketing sense. In a literal sense. Banks, hospitals, governments. When the runtime gets more efficient at the memory model level, the aggregate effect across that installed base is measured in megawatts saved, latency shaved, hardware not purchased. And it's open. Every line of this work is public. Every design decision debated in the open. The JDK is how infrastructure should be built. Carefully, publicly, for everyone. 4 stories and every single one is open source. I love days like this. Story 4. $4.55. One commenter dropped their last 30 days of usage. 3,400 API requests. 323 million tokens processed. And the bill came to $4.55. Run that forward. That's not a rounding error on a cloud bill. That's the cost of a latte replacing what would have been hundreds of dollars in compute a year ago. DeepSeek just put V4 Flash into public beta, and the numbers deserve a closer look. Terminal Bench 2.1. 82.7. Deeps LEE. 54.4. This is a 300 billion parameter model. The previous V4 Pro preview ran at 1.8 trillion parameters. Flash is beating it. A model roughly a sixth the size is outperforming its bigger sibling on coding benchmarks. Pull this thread to its logical end. If capability per parameter keeps compressing at this rate, the assumption that you need trillion parameter behemoths to do serious work collapses. The entire economics of AI inference shifts. You don't need a data center scale deployment to run a frontier-capable model. You need clever architecture and good training data. DeepSeek has been proving this thesis since V2's mixture of experts breakthrough, and V4 Flash is the sharpest evidence yet. The engineering here is worth admiring on its own terms. They're shipping what they call a DeepSeek harness, minimal mode for agent tasks. A lightweight framework that lets Flash run coding benchmarks at max effort with high-temperature sampling. The benchmarks aren't synthetic either. Full-stack development tests, hard coding problems, tool use evaluation. One commenter described running Flash inside their development environment with MCP servers and context reduction tooling, handling 30-plus turn sessions on complex implementation tasks. Another said they've moved 90% of their work to Flash. Because, for reasons they can't fully explain, it outperforms Pro. And the weights question hangs in the air. Multiple commenters asked it. DeepSeek has historically released weights for their major models. V4 Flash is API only for now. The moment those weights drop, every hobbyist with a multi-GPU rig, every startup that can't afford API dependency, every researcher who wants to fine-tune for their domain, they all get access to a model that trades blows with the best proprietary offerings. The tools exist. The cost barrier just lost another zero. What gets built next is the interesting part. Moving on. 15 megabytes. That's the entire APK for an app that opens PDFs, Word docs, Excel spreadsheets, PowerPoint slides, photos, video, audio, markdown, and source code. On a platform where Microsoft Office clocks in north of 400 megabytes and wants access to your contacts, your calendar, and a persistent internet connection so it can phone home telemetry you never agreed to read. Gander takes the opposite approach, and the engineering is worth pulling apart. The fundamental constraint on Android is the permission model. Every app declares what it wants access to in its manifest, and the OS enforces those boundaries. Most file viewers ask for broad storage permission, which means they can see everything on your device. Gander asks for nothing. 0 permissions. Not even internet access. And here's why that matters technically. On Android, if you don't declare the internet permission in your manifest, the OS kernel level blocks all network socket creation for your process. This isn't a policy. It's enforcement. The app is physically incapable of exfiltrating your data because the operating system won't let it open a connection. Now let me play devil's advocate. You could argue this is a toy. A real productivity app needs cloud sync, needs collaboration features, needs the full rendering fidelity of native Office. And for some workflows, that's true. But run this forward. How often do you actually need to edit a document on your phone versus just read it? Most of the time, you're on a train. Someone sends you a contract. You need to confirm a number in a spreadsheet. You want to check a slide deck before a meeting. You need a viewer. And for that, you do not need 400 megabytes of Microsoft surveillance apparatus. The technical trick is elegant. Gander uses Android's storage access framework, where the OS itself hands the app only the specific file you selected. Office formats render inside a sandbox web view with every request intercepted. Bundled JavaScript libraries load from local app assets. Document data streams from the content URI. No network stack touched. Private by construction, not by promise. The community response tells you something. People immediately asked for F-Droid publishing, ODF format support, store availability. They want this to exist. They want a file viewer that does one thing well and respects the person using it. This is builder culture at its finest. One developer, open source shipping, working code that solves a real problem. The tools exist. 15 megabytes. Everything on device. Nothing leaves your phone. What happens when you take that same builder energy and apply it to how we collaborate on code itself? I spent 6 months on a system where every deploy was a single monolithic diff. Hundreds of files. Reviewers would open the PR, scroll for 30 seconds, leave a thumbs up, and move on. We called it review. It was closer to surrender. The thing about code review is, it works like digestion. Your stomach doesn't process a whole meal at once. It breaks food into progressively smaller components, each stage extracting what matters before passes the rest along. Bolus to chyme to absorption, the chemistry only works at the right scale. Hand your gut a bowling ball and nothing happens. That's what a 900-line PR is. A bowling ball? GitHub just shipped stacked pull requests in public preview, and the interesting part isn't the feature. It's the timing. Grackit has offered stacked dips for years. Meta's been doing this internally since the Fabricator days. The pattern is well understood. Break a large change into ordered layers. Review each layer independently. Merge the whole thing when it's ready. This is not new computer science. This is table stakes that the largest code hosting platform on Earth is only now getting around to. And the implementation looks solid. Each PR in the stack targets the layer below it. Merge one layer and everything above automatically rebases and retargets. your branch protections still apply. The CLI extension is 4 words to install. Tim Newton says they've been using it on Next.js for months. John Rezid is landing 5 stacked PRs into a merge queue at once. The testimonials read like the feature actually works, which in public preview is not guaranteed. One commenter notes that merging entire stacks is still broken in several cases. Here's what's worth paying attention to. The blog post explicitly mentions coding agents. Ageni-rated PRs are getting larger and more frequent, and the old review model, one human squinting at one massive debt, was already failing before agents entered the picture. Stacked PRs don't just help humans write better code. They create a structure where AI-generated changes become reviewable at all. The fact that this is built into the platform matters. Open tooling wins when the infrastructure supports it natively. 1,000 teams shouldn't need a third-party service to do what the Forge itself should handle. GitHub took its time, but the bowling ball era is ending. We've covered a lot of ground today, but this next one might be the headliner. Let's talk about DeepSeek. In 1995, MySQL launched as free software against Oracle, Sybase, and DB2. The incumbents charged per processor, per connection, per query. MySQL was worse on every benchmark. It didn't matter. When the cost drops far enough, adoption physics change. The question stops being, is it as good, and becomes, is it good enough at this price? MySQL was good enough. It ate the database market from below. DeepSeek v4 Flash is that moment for frontier-class language models. The numbers are precise enough to be damning. Intelligence Index score of 50. The median among comparable models is 17. 3 times the median intelligence at roughly half the median price. Input tokens at 14 cents per million against a median of 25. Output tokens at 28 cents against 88. One commenter ran the comparison against Luna and found DeepSeek beating it on cost per task by a factor of 2. The model is verbose. 210 million tokens generated during evaluation versus a median of 62 million. It thinks out loud extensively. That verbosity is part of the architecture, not a flaw. At 28 cents per million output tokens, thinking out loud is cheap. The total valuation cost was $237 for a model scoring at the frontier. Run the open-close test on this. DeepSeek publishes weights. The API pricing undercuts every major proprietary provider. A lab in Hangzhou, operating under export controls and chip restrictions, built a model that scores triple the median on a standardized intelligence benchmark and priced it below the floor that American labs treat as their competitive moat. The weights are downloadable. The architecture is document. This is the MySQL pattern. The incumbents are selling per-seat licenses to a product that an open lab is giving away. The gap between open and proprietary pricing isn't narrowing. It's inverting. DeepSeek isn't catching up on price while trailing on capability. They're leading on both axes simultaneously. The million-token context window is almost an afterthought at this point. A year ago, that would have been the headline. Now it's table stakes for a model that costs 1/7 of a cent per 1,000 input tokens. The tools exist. The weights are available. The pricing makes the competitive landscape legible. When an open model outperforms at a fraction of the cost, the value proposition of closed systems becomes purely institutional inertia, and inertia is not a business model. Now, a left turn from benchmark wars to something genuinely unsettling about the research pipeline itself. What happens when the system designed to filter knowledge becomes the bottleneck that corrupts it? A researcher flagged 2 papers at a major AI conference. Fake authors, names that don't correspond to real people, fabricated institutional affiliations. Both papers were accepted as orals, the most prestigious category of acceptance. The one says this work is so important, we're giving it a dedicated speaking slot. The peer review pipeline is eating itself. Papers written by language models submitted under invented identities, reviewed by people who've been conscripted into reviewing 4 or 5 papers as a condition of their own submission. The reviewer doesn't want to be there. The author might not exist. The paper was generated in an afternoon, and the conference stamps it with institutional legitimacy and moves on. Run this forward. Conferences require submissions to generate reviewer labor. More submissions mean more reviewers, but the reviewers are increasingly people submitting generated work to meet their own publish or perish quotas. The review quality drops. The acceptance threshold blurs. The generated papers get in, which generates more citations, which generates more submissions. It's a flywheel, just not the kind anyone wanted. The comments on this one land with precision. Someone points to the monthly ArcSub submission stats and suggests they'll need a logarithmic scale by 2027. Someone else invokes Chavda's paradox. The observation that when you optimize hard enough for a metric, you eventually produce a system that's indistinguishable from one generating random noise. The comedy here is structural. Publish or perish was supposed to ensure rigor. Mandatory reviewing was supposed to ensure quality. Both mechanisms, under sufficient pressure, now produce the opposite of their intended effect. The system isn't broken from the outside. It's breaking from its own internal logic. And this is where the bootstrapism lens actually matters. Peer review is a closed system. A small number of gatekeepers decide what counts as knowledge. When that gate rusts shut, the answer isn't to polish it. It's to ask why the gate exists at all. Open preprint servers, open replication, open datasets. Let the work speak. The institutional stamp of approval is becoming the thing it was supposed to protect against. An authority claimed decoupled from actual quality. The tools to evaluate research openly already exist. The question is whether academia will use them before the conferences become indistinguishable from what they're supposedly filtering out. Google just gave robots a body that actually understands itself, and this one's worth getting excited about. A robot crouches down, picks up a sock from under a table, stands back up, walks to a laundry basket, and drops it in. Then it does it again and again. Each time slightly different. Different sock, different position, different obstacle in the way. This is Google DeepMind's Gemini Robotics 2, and the thing worth paying attention to isn't the sock, it's the architecture underneath. For decades, robotics has been stuck in a loop. You program a robot to do one thing in one environment with one body. Change any variable and you start over. Gemini Robotics 2 attacks this from a fundamentally different angle. It treats robotic control as a reasoning problem. The same model that understands language and images now reasons about how to move a body through space. Whole body, feet, legs, torso, arms, fingers. All coordinated through a single intelligence layer. 3 models working together. One for dexterous manipulation, threading needles, folding fabric, handling objects that deform. One for full body, locomotion, and interaction. And one lightweight model that runs locally on the robot itself, which matters more than it sounds. On-device inference means the robot doesn't need a cloud connection to function. It thinks where it stands. The transfer learning piece is the quiet breakthrough. Adapting the system to an entirely new robot body takes hours, not months. That's the difference between a technology that works in a lab and one that works in the world. One commenter compared it to early ChatGPT. Slow, clumsy, obviously limited, and obviously on a trajectory that makes the current state irrelevant within a few years. The question nobody in that comment thread is asking directly: who owns the intelligence layer? Right now, Gemini Robotics 2 is a Google system. Proprietary. The robot bodies are open-ish. Multiple hardware partners. But the mind is closed, and in robotics, the mind is everything. The body is commodity hardware. The model is the moat. If robotic intelligence stays locked inside one company's API, we're not building helpful robots. We're building a dependency. The actuators will improve. The bodies will get cheaper. The real question is whether the intelligence that drives them will be something the world can build on, or something the world rents. Moving on. One commenter drops the real answer in a single sentence. A Git tracked folder, files as state, agents coming in and doing work. That's it. That's the whole design philosophy, hiding in plain sight. Marble OS is asking what the GUI for AI agents should look like, and the most interesting response isn't a GUI at all. It's a file sifting, files as state, diffs as history. The operating system you already have, treated as the interface it already is. But pull this thread further. Run this forward 3 years. Every application on your machine is essentially a loop. Read state, transform state, write state. Chat interfaces flatten that loop into a single scrolling river where context drowns. Marble OS tries to fix this by surfacing files, tools, tasks, and outputs in a spatial workspace. That's a genuine improvement. Visible state beats buried state every time. The engineering insight worth admiring here is the recognition that agents aren't conversational partners. They're workers, and workers need workbenches, not chat rooms. You don't manage a build system through a messaging app. You shouldn't manage an agent fleet through one either. Now, the comment thread splits predictably. One camp wants having window managers. Another wants everything in the terminal. Someone pitches Dreamcoder. And honestly, all of them are circling the same realization. The chat paradigm was a convenient first draft, not a destination. What matters is that these are all open experiments. People building shipping, arguing in public about what the right abstraction layer looks like. Nobody's waiting for permission. The workspace metaphor, the file system metaphor, the spatial metaphor. Let them all compete. The tools that survive will be the ones builders actually reach for, and builders reach for what they can modify. This is how interfaces evolve, not by committee, by collision. This has been your daily tech feed for Hacker News for July 31st, 2026. This podcast is entirely AI-generated. Scripts by Claude Sonnet 4.7. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that outlasts the tools you built it with. We'll see you back here tomorrow.